Welcome back to my YouTube channel. Okay, so it's been a while since I've uploaded a YouTube video. I've been extremely busy doing up a room to complete my research studies in during the summertime. Also, because of the poor weather lately, it has been delaying me uploading the final part of my mechanical iris, so my large aperture. And also the new project, the Green Beast e-bike build and the battery build for it, that I really wanted to create outside to enhance the lighting conditions rather than being stuck in the shade behind us here. So much of my videos I like doing outside, demonstrating them outside because you can show more clarity on the projects themselves. So it's quite dark in the shade at times. So the sun has only really appeared in the last couple of days. Lately it's just been one rain all the time, every time I go out. Not good, typical Northern Ireland. Okay, so I have decided to continue with an interesting project that I started back in late September last year, until the weather gets a little more dependable to do the aperture and the e-bike. I don't want to be bringing the e-bike outside and all the battery cells getting damp and wet with the rain. So that project is the DIY miniature spot welder, or wire frame crimping and merging spot welder, shall I say, welder system. So there might be a bit of traffic going up and down, so just ignore it. I've set up outside for this introduction so everyone can see clearly all the items I'm about to discuss on the table if they haven't done already. So during part 1 last year, I demonstrated the modification of the 2 transformers and the design and the build of all the systems control seen to the right of me here. So the low voltage side and then the high voltage side. After that, part 2 came in late October, where I demonstrated a smart mechanism that forms this miniature handheld device of the stainless wire frame welder. So the links are in the description for those parts of the project. Keep in mind, when I say the little part that I done in part 2, that is only one part of this completed handheld device. So just to clarify, this project was initially started to assist another project, Model, the third of its kind seen here on the left. So this is the start of it that I am creating for my girlfriend. The title of that video is First Date Helicopter Ride Custom Unique Resin Model Anniversary Gift, as far as I mind, part 1. So the link is also in the description for that project. I started this project in June of last year. Sadly, that project was put on hold until this one is complete. So it's required, this project's required for this one. Sorry, Donna. So what I'm looking to achieve with that model is a large heart structure. So very similar to this template. So these round bars, these curved bars, were formed using this template. Well, they were formed in the Blender, but this template was used to get the varying radius. So this large heart structure consists of 48 specially formed bars and rings. So here's the rings that need to be welded together in a heart shape, like this template. The idea is to keep the heat minimal to avoid distortion, but I also don't want to see any welds, as it's a showpiece, a model. Because of the complex nature of both projects and how they are linked or how they are combined, I think it's beneficial for me to draft a few sketches early on here to explain exactly what it was I'm looking to accomplish and where this video part 3 is going. So I say was because the device is now complete. This is the final part of the handheld device of this wire welder merging system. After I complete these sketches, I will then demonstrate the steps I took during the design and the build stage, adding to the stainless copper device created in October. So that's just the capsule I'm talking about. Okay, to proceed, the second electrode needs to be directly placed inside the heart structure for these invisible welds to be completed. hidden might be a better word here. So what I'm trying to say is, this special electrode seen here now on the end of this needs to be designed in such a way that it can fit inside the small rings. Like so. In more detail, the electrode will allow the device to crimp and to transfer current in the correct direction, taking the shortest path across the points of interest. So across the workpiece at this point and this point. Without this new electrode, this fixed electrode seen here, this outer sliding electrode that I created in part 2, the entire system would be useless. Because of the complex stainless heart structure also, this was very tricky because everything needed to be small but effective for the welds to be successful, especially at the smaller inner radius of the heart structure. So what I'm talking about is, this part of the heart structure tends to be a nice curve, but it's a tight radius. If you can imagine me placing this device into the inner side of the heart, it would be tricky. So with these rings in the inside, well, that is the inner part of the heart. So if you can imagine now this heart like this, yeah, it's still going to be tricky. It's quite a tight radius. So I'm going to start attaching the initial design sketches here now and take it from there. Okay, so hopefully you can see this sketch nice and clear. If not, don't worry about it, I'm going to go over it with a permanent marker here. So I have drawn it out here roughly just to give an idea of what I'm trying to achieve. So if I go over these lines and just mention what they are. So we have the frame here at this point. So this is the outer bar. So this is a 3.2mm bars on the outside. We then have this 5mm broader stainless bar in the center. And we also have this on the inside of the stainless structure too. So what I have done here is I've drawn the welder in position and the rings. So here's the rings here now. So I'm just drawing 2 rings. Now the welder. So basically this is like a plan view looking down on the stainless wire structure with the welder in position. So this is a copper bar here. This solid bit here. So what I want to do here is I want another copper bar protruding down the inside of the stainless structure. So into the center of the rings, if that makes sense. And we also want this copper electrode to be tight as possible against this 5mm bar. The reason being is we want the electrode as close as possible to the center of this bar, so it lines up with the sliding electrode seen here. So this copper electrode will be fixed to the stainless body at this point with a bolt running through here. Okay, so what I've done here now is I've drawn the welder and the frame a cross section view. So I'm going to go over it in permanent marker and explain what's going on here. So we have the 3.2mm bars here at this point, 2 of them at the side, 1 at each side. We have the 5mm bar at the bottom and another 5mm bar here at this point. Then we have the 30mm ring on the inside. Then we have the welder device seen here, so the sliding device with the copper electrode. So I'm going to draw the stainless part first. Then we have the copper electrode seen here, sliding in and out. And we have it here at the top too. We have a hole for VS plus terminal. So that's obviously going to be AC power coming from a transformer, the two transformers. So terminal, then this is the next part now, that's really important. So we need this second electrode to run down to the inside of this ring. So we need it to be skimming this 5mm bar. So this will be sitting this way. So this here will be a weld point here. Then we will have another electrode in here. So I'm going to draw it on here and then I'll explain it. So this is the second electrode. Then we have stainless plates that this copper electrode can be fixed to. And I have fixed it here using countersunk screws. Like so. And the negative terminal of this device will be connected to the body, the stainless steel body. Or it could be connected at the point we connect the spring. So this spring is here to keep pressure on the pinch point. Okay, so the next point of interest with this drawing is around here. So the reason I mention keeping this copper electrode as tight as possible to this 5mm bar is because we want this second electrode to be in the center of this electrode, this point, and also the center of this 5mm bar. So to do that, we need to attach another copper plate in here to allow for that. Because at the minute, if I was to place another copper bar here, it's only 3mm thick. 3mm is not going to take us to the... It'll take us a half a mil past the center of the 5mm bar, but we need to go a wee bit more. Maybe 1mm or 2mm more. So I'll get into that now with another drawing here. Okay, so I have drawn the copper electrode coming down here. So this is coming down from my device. So this copper bar will be connected around this point of my sliding mechanism. Then we will have another piece of copper that bolts directly to this piece of copper. So I'll draw it out here. So here's the hole where this copper will be bolted to the other one, the other piece. Then we will have this piece of copper running off in a small angle. So the reason it's running off in a small angle, as I've mentioned there, is to allow for the electrode to hit the center of the ring. So this piece of copper will have a round edge on it, so it won't be square. So it'll be much like a hump here at this point. Can't draw it with a permanent marker, so I'll draw it here this side. It'll look like such. It'll have a hump so it doesn't flatten the rings. Okay, so what I've done here now is I've drawn a sketch in an isometric view. So I'm going to start here by just going over the lines of the wire frame first. So here we go. So this is the 5mm bars, top and bottom, 5. And then we have the 3.2s. So you'll see that one running right through. Then we'll have the ring. Okay, so top bar now. So 5mm bar. And then we will have the welder itself. So this is what I want to explain. So here is the new copper electrode passing down the side of the 5mm bar. Then we have this little copper piece bolted to it, which basically brings the copper out away from this one by approximately another couple of mil, just so that this electrode lines up with this electrode at this point. So this is the other electrode here, the sliding electrode. So that's basically it. So what I'm going to do now is I'm going to move on to maybe just start designing this on SolidWorks and seeing where it takes us. Then we will start manufacturing it out in the garage. So again, this is a weld point here, this is a weld point, this is a weld point, and this is a weld point. So 4 weld points to each ring. So it's 40 rings, so that's 160 welds. So that's a lot. Okay, so I will run through this quickly to get out to the garage as soon as possible here. So the first thing I have done here is model up all these parts that I have just sketched. So they are in the tree here on the left, the design tree. They are currently suppressed. So starting with the capsule that I have already created. So I have added this new supporting plate seen here. So I'm going to go through this and unsuppress each one of these new parts. We have also added this new tab, which is welded directly to the supporting plate. Then we have this new copper bar, copper electrode. We also have a part 2 of this electrode, or 2 parts to this electrode, at the bottom here. So you can see this little bend that I was drawing there, sketching. So this bend is to bring this electrode to the center of the sliding electrode. Then we have all the fixtures. I will also unsuppress these. There we go. So I'm trying to keep the device as compact as possible to fit in around the hard structure to be created. So we have the sliding electrode seen here contained in the stainless capsule. So this sliding electrode is isolated from this one using these insulators inside. I'll suppress this plate here so you can see the red insulators. This is fiberboard, high temperature fiberboard. So my idea is to have this fixed electrode seen here passing down the side of the device with another piece of copper fixed 90 degrees from this piece of copper. These pieces will be directly bolted to each other, so they are tapped. There's no nuts used to keep the device as non-obstructive as possible. I have also added this little cap screw seen here. So this cap screw is there to keep the second copper piece from pivoting or moving around when the sliding electrode is pushed upon it. So seen here. Okay, so that's messing about since I unsuppressed that. So I'll place that back in. So this sliding electrode pushes against this lower part here. This cap screw keeps these 2 parts perpendicular. So as you can see here, this electrode or this device is pinching the, well, it will pinch the stainless bars that are in between them. What I will do here to aid this discussion is open my hard model to be created and place this prototype in position, or in a position. Okay, just before I move over here to the hard model, I just want to set this sliding electrode open to its maximum limit. So here we have the hard structure, the hard model. So if I place one of these welder devices here in at the top, you can see how it fits in around the little 30mm rings. So within the stainless wire frame structure, there will be tighter or more awkward spaces depending on the position of the weld. So if I open another one of these down closer to the bottom of the hard structure. So if I was to attach cables to this device from the transformer, you can see that there's no obstructions in the way. So if I add another one of these welders now to the tighter, more complex area of this hard structure, you can see how things start getting a little bit more complex and more complicated. So this is why I have had to design this device to the standard it's at. So very small, the capsule being very small, the main part of the welder device. So if I open another one of these now, unsuppress it. So here you can see how things become a bit more tricky as the little rings get closer together at this tighter radius. So I will need to be careful with the cable mount points, the locations of the cables, when I'm going to weld this hard structure. So the cable needs to be as flexible as possible too. So I'm now going to extract a few drawings from these new parts and proceed to adding to the sliding capsule. I think this makes an interesting project, so enjoy the process that follows. I should also point out, this little curve in the new electrode might be required. I am not sure yet. It might be required for this more tighter, compact placement of the rings. So you can see here at the top of the heart, the rings are further apart. You can see here on the inside that these rings are much closer together. So I probably will need to gouge a wee bit out of the copper bar when I go to do the model. Okay, so we're out in the garage for the first time this year, thank goodness. So we have this little smart device that I created last year. So my next step now to follow on with this little handheld device is cutting this little stainless supporting plate. So this plate is very crucial for this little device to work. If this plate wasn't on this little face here, if I didn't attach this plate and I welded this tab directly to this smart sliding device, we would end up distorting this piece of stainless. So this copper bar would tighten up, binding issues. We don't want that. So we want this copper bar to be nice and free. So after I finish this stainless plate and this one, we will move on to this copper electrode, which will be directly bolted to this special tab. After this electrode is complete, after it's cut out and the holes are drilled and tapped, we will follow on to this little piece. So this is also a part of the electrode that creeps in to the little rings, the 30mm rings. So I'm going to follow on with this now, and we're going to tape these little templates down on top of the stainless steel using masking tape. So I have my mask ready, I have my grinder ready, and I have the welder ready. So hopefully everything goes as planned here. So we're going to start off now with this supporting plate using this bit of stainless. So it doesn't matter if it's marks below it, but this is Mur grade stainless, so this will be Mur face up. We will have this bit of stainless for this tab. The reason I'm using this bit of stainless is because there's no marks at this point, so rather than using new sheet. So we're going to proceed here now and hopefully it all goes well. Okay, I should point out there, I mentioned I don't want scratches on this plate. The reason being is you'll see both sides of this tab once this tab is welded to the device. This face, or this plate, you will only see this side. So if I remove this vinyl layer here, on both plates we'll have a nice mirror finish. On this side we have like a 2B finish, but we don't want scratches on it. So what I'm going to do is I'm going to keep the copper bar to this side of the, what do you see if I put it in position here? So I'm going to bolt the copper bar, the copper electrode, directly to this piece of stainless. But the face of the copper bar will run along here. So I'll keep the mirror side to the opposite side of the copper bar, if that makes sense. So I'm going to start cutting these sketches out roughly here now and using them as templates. Then we will tape them down and we will scribe the stainless. There we go. So I'll tape these down and we will proceed to cutting these out with the grinder. Then we will file them and hopefully get them nice and square. We will drill the holes on this tab first before we start cutting the plate, so we have something to hold on to. Okay, so what I like doing here is working off one straight edge. So one side of the template is lined up to a straight edge on each one of these plates. So basically by using this straight edge and bringing the template in tight and then taping it down. Simple as that. And then we will proceed to, well, cutting it out. So I'll just line this up by for this demonstration here. So taping these two edges and then we will cut around it with the grinder. But what we're going to do first is we're going to scribe it with a straight edge along these edges using the Stanley knife. But we're going to tape here first. There we go. Okay, so there we have the nice scribed lines. So now I'm ready to cut this out with a grinder and then we will file up to these lines if there's any wee bits needing filed off. Before we cut this plate out, we're going to drill the holes on this plate, then we will cut both plates out together. So remember, this one needs scribed yet. So I'm going to centre punch these holes first. There we go. So we'll drill these now. Well, we're going to drill them out to 5mm, so we're going to put a pilot hole through first. So a 2.5mm bit first. So me moving the drill about and a wee angles just to sort of direct the hole into the centre. Stainless is hard to drill. So that's near enough. 5mm now, and then we will move on to tracking this outer line off this template. Okay, so what I have done there off camera is just centralised those holes to the template using this Dremel. As I've mentioned there, stainless is hard to drill at times, so especially with blunt bits, drill bits. So what I'm going to do here now is I'm going to run the 5mm bit through them. I have brought the holes, as I say, into the centre of the sketch holes. So I'm going to run the 5mm drill bit through them here now. Looking good. Perfect. So when your camera, you're recording things with the camera here, things can be a wee bit more difficult. So I'm going to now track this outer surround with a Stanley knife again off this tab. So this is going to be done a wee bit different, obviously, because it's round. So what I'm going to do is I'm going to just freehand go around it with the knife. And we will get an idea of where it needs cut and grinded. Well, we don't need the bit to move. A bit of paper. Okay, so that's near enough. There we go. So that should be scribed. Following the template closely. There we have it. So we have this little line, little fine line. You might be able to see it there. If I move the plate a wee bit. So we'll cut these out now, both of them. And we will file them and then we will start welding things together. Okay, so what I've done here is I've left a bit so I can hold on to the actual stainless plate, so I can cut this curve, this concave radius. So I'm going to do that now, and then we will just cut it off clean at the end. Need to remove the vinyl first, I forgot, on this plate. We don't want it to melt into it. It probably already has, but we'll remove it anyway. Yeah, it has. Yeah, we'll get it off. There we go. Bit of thinners, we'll remove the adhesive later. Okay, there we go. So the next step now is filing this into the scribe line. So we'll use a grinder first to take off the rough of it. Then we will just finally finish this piece by cutting it off here. But we'll tweak this edge first, these edges, before we get to this point. Okay, so that's me ready to cut this tab off. When it's cut off, we're going to finish off tidying up this little radius at this end before we start using the files on this. Just with the grinder first. After I do that, I have to also tidy up this plate yet. So I'll do this one first, then we will move on to this one. Okay, so I'm going to finish these off. Just doing it off camera so I can put my full focus on them. So to get them right, I want them right for the project. So I'll do that, and then we'll start off again now by welding these pieces together. Well, obviously on the smart device. So this will be welded to here, and this tab will be welded around this point, like such. Hopefully you can see that nice and clear, because I cannot see the camera recorder screen at all today, looking up at the bright ceiling. So we'll tidy these pieces up and then we will continue on with welding them. Okay, just a final demonstration here before we move on. So we are ready to weld these pieces together. The sliding mechanism, the supporting plate, and the tab for the second electrode. So these edges are all polished up, so there's no grinding marks or cutting marks on the edges at all. So what I have done here is I've used this Dremel and this little sanding drum to swiftly go over them, removing any marks. So this plate is the same, so you can see it's nice and polished. We don't want the grinding marks in it. So I'm going to move on now and start welding this little device, finishing it off, and then we'll move on to the copper electrodes. So again, we have to get the drawings. We have these final two pieces to complete. So this is one copper electrode, and this is part of the lower end of the same copper electrode, which will be bolted to it. Okay, so we are ready to weld this little plate to the capsule that I created last year. So we have it lined up, to this face and also to this side face. So that means that it's going to be in line here and at the rear side of it, because the plate is the exact same size. So what I'm going to do here now is I'm going to tack this corner, and then we'll move on to the rear here. Keeping in mind, the reason this plate is here is to support this new tab. We don't want to weld this tab directly to these guides because, well, the capsule, these 4 plates, existing plates, because we would only distort the plate and then the insulators will become tight and the copper bar will not move as it should do. Okay, so we're going to tack this now. We'll place the earth clamp on it and away we go. So we tack here first. Okay, so that's one tack to the corner. We're going to do this side now. Make sure it's still square or flush. Looks good. Okay, so we're going to have to tack it in this position. That's 2 done. So the rear side now. And hopefully this still moves as it should. Okay, so I don't know if I mentioned there, but them insulators are pulled out so we don't burn them when we're tacking it. So what I'm going to do is I'm just going to take the whole lot out for these last 2 tacks for the meantime. 2 welds. So again, we're going to tack the corners. 1. Final tack. There we go. So that's it. Next step now is welding this tab on. So this tab needs to be offset from the face at, what do we see, what side it is? Either one of these sides. I need to get the drawings to check this out. It's either this side, obviously, or this side. So it has to be 4 mil. So what I'm going to do here is I'm going to set 2 pieces of plate on this side, and we will then get our distance. So I'm going to get the drawing just to see what side this is at again. Keep it the same as the model, you know. Okay, so I have went and printed out a new drawing here to benefit this explanation. So this tab that I have been discussing does not run up the center of the capsule. It sits offset from, well, one edge of the capsule. So if I just draw this out, so if you can imagine the capsule like this, there's the center. This plate sits, this tab, shall I say, sits 4 mil from one side of the capsule. So I have it set up and all ready to weld here. So what I'm going to do is I'm going to tack it in 2 positions. Either corner of the tab to the new supporting plate. So I'm going to set the welder up here now again, or turn it on here, and we're going to start this process. Okay, so I didn't mention there, I have this little tab clamped in position using 2 clamps. So the way that I have done this is I have the capsule, one side of the capsule, clamped to this flat plate. Also, we have the tab clamped to this plate too, but in between this plate and the tab we have a 4mm gap. We have this gap in place using 2 packers. So these packers are 2 mil thickness. So what I'm going to do here now is I'm going to put a tack at this corner. We're going to release the clamps and then we're going to see what it looks like. And then we will weld the other side if all's okay. Okay, so I put a good tack on it there. So I will release this now. See if it's square, and then we will weld the other side, tack the other side. It's looking good. Okay, there we go. So I'm going to square it up here, and then we will tack the other side. Okay, so it's looking good. So if I set these two plates on top of this now like this top plate should be flush with the capsule at this point. Let me see if I can get it in. So if I put this straight edge across it here, it should be flush at both sides. So it's looking good, so I'm going to put another tack on it here. Here we go. That's it. So next step now is making the copper electrode. We will finish off welding this. Well, we'll finish the electrode first and then we'll finish welding this. Just make sure everything's okay with the electrode side. So that's it. Okay, so my next step is starting with this longer electrode. So I have the bar cut. I have one of the holes tapped out to 5mm. I also have this section done, the small section, the small part. So my next step now is putting a fold in this. So if you look at the drawing closely here, you will see a slight fold. After approximately, I think it's about 20mm. So it's only a very slight fold, say like 5 degree, 10 degree angle. I should probably just demonstrate that this copper bar still slides as it should do when the little tab is welded on, now that it's cooled down. So we don't want this too slack, we want it just nice and snug. This can be altered a wee bit by sanding the bar by emery sandpaper, fine sandpaper. If you want it a wee bit slacker, which I will want it a wee bit slacker, because there will be a spring on this. So we're going to start here now, cutting this bar, drawing the rest of the holes first, putting the fold in this one, and take it from there. So we'll start with the big one, we'll bore the holes in it. So this electrode will sit in this position with the hole to the side. I will place another hole here for the actual cable, the high current cable. So we'll start this bar now and we'll bore the holes first. You might forget about this radius for the meantime. We don't want to weaken this electrode too much, but we need to allow room for it to fit into the centre of the 30mm rings. So we'll do the holes first. First things first, I'm going to cut this bar to size. Okay, so now that we have this little electrode, the copper bar cut to length, we are going to bore or drill these two holes. So we also have a little tapered part that I have filed out using well, the grinder and the file. So the reason I've done that is to allow this copper electrode to sit nice and snug or nice and tight to the plate, because if I didn't do that, this weld was obstructing it. So the best way to bore these holes now, to mark them, is to set the plate down and basically run the square across the first hole. Then line it up. I've already done this. Then line it up with the device and basically draw around it with a permanent marker. So we'll do that now, making sure that the copper electrode is in position. So it looks good. So we'll draw these out to 4mm and then we'll tap them to 5mm for an M5 bolt. So these will be dome head bolts, stainless bolts. So that's complete. I'm going to tap them out now to M5. Okay, so I have a tap, M5 tap in the drill, and basically I'm just going to go gently here, tap us out. Nice and square. Okay, so that's one hole done. On to the next one. Making sure it's nice and square. Okay, so that's two done. I'm not going to run the tap right through. I want the bolts to be nice and tight in the copper. Okay, so the last hole in this little copper electrode is the hole that's required for the high current cable. So it's really a terminal location, or a terminal spot even. So what I'm going to do is I'm going to tap it out to M5, and I might put, I might just take it on out to M6. But I'll drill a hole anyway, 4mm at the meantime, and then we'll see later on what size we will take it out to. So I have it marked here now. So a pilot hole first, I think it's a 3mm drill bit. Keep it in the centre of the bar. Good job. We'll take it out to 4mm. Okay, so next step now is moving on to this second part of the electrode. So it's much smaller. So the first thing I'm going to do here is I'm going to put the fold in it. Just at this little M3 hole that I have tapped. So we'll do that now. Okay, so before we move on to the final piece of this device, well, the final piece of the electrode for the device, I want to just discuss something that's, well, that I forgot about, to be honest. So back in October, I mentioned this was the front end and this was the rear end. So the reason being is I want to keep these screws, this removable piece, away from the front end of the welder. Just so it's not too clunky or too obstructive. So what I'm going to do here now is I'm going to bolt this on, and I will explain why. So the copper electrode sits here like so. Okay, so that's one screw in. We'll put this one in too, and then I will just discuss what I'm talking about here. So you want as much room as possible up around this end. So the final piece of this welder now will be a little piece coming across like so with a bend in it. Then we'll be able to connect our cables to this point and this point. Or sorry, this point and this point. So I'm going to move on now to the electrode, this part. We'll finish off by placing a fold in this and cutting it. And we'll bolt this onto this. We also need to apply a wee notch here. I'll explain why when I get there, but again, this is the front face, this is the rear end as spoken about in October. In the 3D model that I have drew last week, I have this the wrong way around. I will correct that. So I will attach it to the end of the video. So we'll cut this now. Or sorry, we'll fold it, then we'll cut it. We'll bolt it onto this, we'll add the notch to this, and the little device is nearly there. So, thank goodness. Okay, so the final stage of this copper electrode is placing a fold at this point. So, this fold is there to bring this copper electrode over into the center of this sliding electrode. So if you look, if I line this up with the camera here, see the way it's a wee bit too far to the left? Well, I want to bring that more towards the middle of this copper electrode here. So what I'm going to do is I'm going to put a slight fold in it to match this drawing. So here we go. Shouldn't be hard. There we go. Perfect. So that is 100%. You be looking at it. So we're going to move on now to cutting this, and then we will see about adding a spring to this mechanism. We might add a stop on too to keep it from touching the other electrode. Let's say about a mil gap or so, because I won't be welding nothing that small. So good job. Okay, so we're ready to cut this piece now. So the second piece of the second electrode. So this is the piece that comes into contact with the rings themselves. So we have a pile of dairy cows in the background there roaring, so hopefully they don't disturb me too much, disturb us. So I'm going to clamp this second piece to the electrode on the device, just so I can hold it through the cutting process with the grinder, because the piece is so small, and because copper's a good conductor of heat, I think it's appropriate to do this so I don't burn my fingers. So that's it clamped. I have it marked and all to match the drawing, the fine line. So here we go. Okay, so I'm going to tidy up this face here, then I'm going to position this second piece, and then I will discuss what this little hole is for here. The little tapped M3 hole. Okay everyone, so we're finally getting there to the last stages. So now we have this little contraption nearly complete. So if you look down the middle here now, straight down, you can see how the sliding electrode comes out to make this new piece, this new small electrode. So my next step now is, obviously if I was to put pressure here, no matter how tight this M5 screw is, this piece of copper will always want to go the opposite direction. So if I push here like so, this will end up doing that. So the reason I have tapped an M3 hole here is, so if I screw a little bolt, a little cap head bolt into the back end of it here, and put a notch in this electrode. So if I have a piece of paper here, I could draw this out, but I'll draw it here on the timber, a piece of plywood. So hopefully you can see that nice and clear. So there's my electrode, there's my main hole. I want to put a wee notch like that. So hopefully you can see that, but I will then have a cap head screw, an Allen key screw, and there's my new piece, my small electrode that I just folded there and cut with the little fold on it. This little screw will help keep these two bars at a right angle. So I'm going to notch this out now using a grinder, a wee fine cutting disc, and then we'll use small files to bring it up to a good standard. So I'm going to do that now. Hopefully it turns out well. Okay, so I'm about to turn this mask on again, this air respirator. So I don't want the copper in the lungs. So we have this little mark here. What I'm going to do now is basically take a little bit out of it in a nice round radius to match this little small M3 cap screw. So this cap screw will sit in here nice and neat, screwed into the small electrode. So the piece here that comes in contact with the copper, or sorry, not the copper, the stainless steel rings. So we're going to start notching this out now, cutting it out. Okay, so I think I've got enough out of it there now to find out exactly where the cap screw is going to sit. I'll mark around it with a Stanley knife. I'll scrape around it, and then we will take it out further with a file. So we'll put it back into position here. So this little dome head screw still needs cut to length, so just ignore that at the minute. So we have this wee screw now, and we're going to screw it in. If I get the right Allen key here. Hopefully this works. Okay, so I need to file this copper bar first, or cut the burr off it. There we go. So next step now is screwing this screw in. We don't want to take too much copper away. We want to keep this nice and tight. Otherwise we'll end up with an angle that's not 90 degrees or not perpendicular. So if I mark, hopefully you can see that. If I mark around this little cap head screw now with a Stanley knife, and then we will file it out. We're not going to use a grinder anymore because that's too excessive at this stage. So I'll mark around this here now. As I say, we want this as tight as possible. So I probably won't go near the mark. I will be on the other side of the mark, if that makes sense. There we go. So my first little cut is not far away. So I'm going to do this with a file now. So I'll get the files here and I will start recording again. Okay, so I have this little half moon little circle filed out using these little miniature files. So I done it off camera there because I wanted to focus on it to make sure I didn't mess it up, because this is my last piece of copper. So I'm going to demonstrate putting this together now, but this is basically what I've done. I've just striked the little copper bar nice and gently out to the little mark, the scribe line. So I didn't remove the scribe line's still there, but I went to the other side of it. So I'm going to bolt this little plate on now. This little copper electrode even, shall I say. So, as you can see now, this little cap head screw is screwed into the second piece of the electrode. And when I fit this into position like so, we can then put the dome head screw back in. So this is actually the first time I put this together. So my next step now is cutting this dome head screw. So as you can see, that is a complete. So no matter how much pressure I push here now, this little 3mm cap screw won't allow the electrode to push away, to move away from the angle. So, excellent. So we're going to move on now. We're going to cut the screw. We're going to put a couple of final welds down this side. I've already welded here. I'm going to chamfer the sharp edges into a 45-degree angle, and I'm going to polish the little piece. Then we will do the final test by attaching the control mechanism and the power unit that I have created for this little device. So all's good. Oh, right, I forgot. The spring has to go on here yet. So, again, basically what I'll be doing with the spring is attaching it at this point. And basically when I pull this electrode back, it falls back into place with a nice amount of pressure on it. So, this little miniature spot welder, or not miniature spot welder, miniature wire crimping welder is coming together rightly. Looking good. So I mentioned there placement of the spring at this point. I'm not going to do that now. I'm going to place the spring here instead. So I'm going to take advantage of a hole that I drilled and tapped when I was doing the welding process here. I didn't mention why I done this hole, but that hole was placed there, so if I was to screw a screw into it, it was to bring this plate out away from the other one, because this copper bar ended up being too tight. So this stainless steel plate sunk into like a belly, like in a banana shape. So that's the reason I threaded this little hole. So what I'm going to do now is I'm going to place the spring at this point. I'm going to do this using a 5mm dome head screw and a nut. So I'll just place this on. What do we see here? Might take a wee minute. So the nut's there to lock the actual M5 little bolt in position. What do we see here if I can get this set up? There we go. So you mightn't be able to see there, but I've got that little M5 bolt tracked so the spring sits out away from the body. Approximately 1 mil or 1.5 mil. We don't want the spring rubbing against the body because I'm going to polish this into a mirror grade. So my next step now is drilling holes in this copper bar for the other mount point of the spring, the other attachment point. So to do this, I'm going to screw an M5 bolt into the copper, and I'm going to leave 2 different mount points so I can tension the spring by moving the bolt out another 10 mil. So you can see the 2 marks here, the 2 permanent marks that I have made. So what I have done here is I've left the electrodes touching, and I have just basically moved the spring out till I got my first point. Then I've added another 10 mil onto it. So hopefully that makes sense, and hopefully it works. So what I'm going to do here now is I'm going to drill these holes using the pilot drill, wee small drill bit, and then I'm going to go out to 4 mil, and then we're going to tap them. The same way we did the other holes in the copper bar, here, 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 and here, everywhere. Oh, this bar too. So I will do that now. Okay, so I have started these holes here just so I made no mistakes. So pilot hole 3 mil first, 2.5 mil, 3 mil drill bit. Next size is 4 mil for a 5 mil tap. Should be 4.2, but 4 mil is near enough. Copper shaft. So tapping it will be no problem. Okay. So we're now ready to tap these out to 5 mil. So again, we're going to use a drill as our tapping device. Okay, so we're going to apply a wee bit of cutting oil here. Okay, so I'm not going to go right through with the tap. We don't want the bolt to be too slack and then frayed. So on to the second one. Making sure the tap's nice and square both ways. Clean the tap a wee bit and back in. Okay, so that's them finished. 2 nice M5 holes for the spring tension to attach the spring. So we're coming near the end. We have the 2 little bolts specially cut to size. We have a nice little cutout so that the spring loops, the ends, sit out close to the domed head. The reason we want this is so that the spring doesn't rub the body off the welder. So I'm going to mount this spring now and see how it works. So we'll start with the mounting it to the body. So the nuts is there to lock the domed head bolt in position. So that'll do for the meantime. Right, now we're going to mount this end, the opposite end. So bringing the spring into the springs parallel to the body, and until the spring falls into the groove of the bolt, which I have cut. So a wee bit more yet. Okay, so that looks good. There's approximately a mil gap that we see. We'll tighten up these nuts. Okay, I'll come out while I'm turning. There we go. So see how the spring sits out towards the domed head bolts? That's because there's 2 small cuts. 2 small little cuts on the bolts. You can see it there in that one. Okay, so I can lock this nut up. That'll do just for this demonstration. So my next step now is welding here and also polishing the body. But first I'm just going to demonstrate this little mechanism working. Okay, so we have a wee problem here. So this bolt is touching the insulators on the inside, so it's tightening them up. So I'll just back it off a bit. There now. So see how that works now. the spring's putting pressure between, well, at least at this pinch point. So if I put my finger in here, I could feel the pressure. So that's what we want. I can't get my finger out now. Okay, so I'm going to demonstrate now placing the bar in. So this is the little stainless bar that I'm looking to weld. So this bar sits this way, like so, and the ring sits in between like this. So obviously when I have it in a frame, it's going to be easier held. Let me see. There's the cow roaring. So there we go. That's the way the little device will hopefully weld these bars together and me apply the current. So you can see there now the pressure holding the two bars together. So when I apply current to this electrode, this terminal point, and to this terminal point here, the current will go down through this copper bar, into this 5mm bar, and across this part where high resistance will be, and into this copper electrode, back into the secondary windings of the transformer. So I will finish off welding this, we'll polish it, and then we'll test it. And if I want to increase the pressure at this point, just say it's not enough, I just move this bolt out to this hole. Or just say that's still not enough. I can go on out to the terminal hole here at this point, which I don't think it's required, to be honest. So I probably will work off this one or this hole 10mm out. Okay, so what I've done here is I moved the spring out to the second hole, and it seems to work better. So if you can imagine, look at the pressure on this now. Hopefully you can see that nice and clear. So with that extra bit of pressure, the bar and the little ring seems to sit there better in the device. So you can see, if I bring that up closely, how this little piece that I designed on SolidWorks, well, I done it in my head first, and then I sketched it, and then I took it to SolidWorks. So you can see how well this little copper electrode sits inside the little small rings. So these rings are 30mm in diameter. I was going to create like a radius here at this point, but I mightn't bother now. So what I'm going to do here now is I'm just going to strip this whole thing on the bench, and we're going to finish off welding it, and then we'll polish it, and then we'll do testing. So here we go. Just going to demonstrate exactly the stripping process now. So I'm going to remove everything. So there's a lot of work on this little device, as you've already seen. Next step is these little dome heads at the side. So let's say that I burn my insulators out of this little device. This is what I do here now. This is a process I go through to get at them. I slide off this little part that I made, like so, and I pull the insulators out. Let me see if I can get them here now. So I don't want to burn these when I'm welding it. So there we go. They all fell out in the bench here. Hopefully you've seen them. So let's say I burn these, which they are burnt because when I was welding here, the heat went down into them. So they're not burnt, they're just marked a wee bit. But I have spare ones cut sitting behind me. When I finish off welding this now and polishing it, I will install new ones, and then we'll do testing. So all's going well. Very good. Okay, so we are outside with the burnishing, polishing machine. I have left these edges with a nice chamfered edge. So I'm going to demonstrate polishing this now using this machine. So I'm using black polish, black bar. So here we go. So you can already see how it's coming up to a nice mirror finish. So the welds could have been sanded out of it, but out of the piece, but I decided to keep them for strength. So I'm going to continue polishing this, and hopefully it looks well when I'm complete. Okay, so I screwed that front face on just to hold it, to polish it. So we're getting there, looking good. I didn't think it was going to look so well. Okay, so I finally finished polishing these parts. So the main body, the main capsule that contains the little insulators, that is finished. You can see the nice reflective finish there, mirror polished. If you look closely, you can probably see the roof off the garage there. Also, this little retainer face, this little retainer clip, or whatever you want to call it, end cap, is also polished into that mirror finish. So I'm going to demonstrate building or assembling this handheld device for one last time. So here we go, we're going to start off with these little insulators. So this is the lower one, but the one with the hole in it. So you can see I have all these little insulators marked this time, so they don't get mixed up. So here we go. 1 to 1 and 2 to 2. Next step is adding this sliding electrode with the single hole facing down. Next step is this top or bottom, whatever you want to call it, insulator piece. Next step is this retaining clip, this end cap. I have it marked so that it matches up to the body. So you see the grinding mark here at this point, and also there's a wee grinding mark in the inside. So this is fixed using these small M4 dome head screws. Okay, there we go. So next step is attaching the fixed electrode, keeping this notch to the welding side, which is here. Also, these 5mm domed head screws are used to fix this in place. Okay, so that's it. Next step is adding the spring. So starting with the body, attaching it to the body first. Again, this is M5 domed head bolts and a little M8 nut to lock this up. Here we go. Now attaching this at the sliding electrode. So I'm going to go with the second hole as it adds more tension to the pinch point between the electrodes. Another lock nut. So these need tightened with a spanner, an 8mm spanner. So that's it. So my next step now is adding the small second part of the fixed electrode. First I need to add this little grub screw. So this keeps this little part from moving when the pressure is pushed on it. I'll demonstrate that now when I fix it here. So the screw goes in from this side. So again, it's an M5 screw. So that's it. So now you can see this little device working, finally. I'm just going to demonstrate bolting these little terminal screws on, or fixing them on here. Oh, this side. So this is one terminal from the, well, a cable from the transformer will be connected to here, or a cable from my control box once it's made. This is the other terminal here at this point on the fixed electrode. Better using the Allen key for this. This side even. There we go. So terminal 1, terminal 2, and we have this little sliding device. So this copper bar is isolated from this body. However, a problem does exist. I've only noticed this because I've been so fixated on the finish line of the video. So if we think about this for a second. If I apply current at this point of the electrode, at the terminal, current will flow down through the copper bar, the copper electrode, and into the second copper electrode, and back out at this terminal point to the transformer. So that is secondary winding in its closed circuit state. That's the way it should be. So if I open this, so what I'll do here is I'll place an insulator between the terminals. So this is now in its open state. So the transformer should be in its open state, an open loop. However, the crimping spring is acting like a resistor, which will limit the current at the weld because of the mounting locations that I have selected. That's required, of course. If the electrodes were in this open state, the spring would burn up, deteriorate instantly. If I had the foot pedal, as it's a high resistance point of the system that's not meant to be there. So in closed state, because the electrodes are shorted, the spring will get warm for a short period. The pedal is pushed, or when my transformers are engaged, or when they're switched on. So the device in this state will still weld, but the spring will limit the current slightly, probably by about 20%. We obviously don't want this, therefore I will fix this small glitch now quickly before we move on. So what I'm going to do here is I'm going to insulate one end of the mount point. So this end here at the copper bar. I missed this glitch, as I say, trying to get to the finish line in a rush. Okay, so the first thing I'm going to do here is cut a bit of nylon tube that fits in between the head of this bolt and this nut. So I have it marked and all here. Okay, there we go. So this is about 6mm on the outside and 4.5 on the inside. So my next step now is placing this into hot water to soften it for about a minute or so. Then I'm going to push it over this new M5 domed head bolt, screw bolt. So I'm going to use this little brake fitting to do that. So here we go. Oh, I'm going to push it against the bench first. Back under the hot water. Oh. There we go. Okay, so now that that's done, I have to have something against this face of the screw bolt so that the spring doesn't contact it. So I've got these little nylon washers. I have them filed out to fit this nylon tube. So when I place the spring on this, I will then add this one. So I'll do that now. Okay, so the next step here is removing the spring. So what I'm looking to do here is change this bolt completely. So I've just I've tensioned the spring a little there so it doesn't rebound and scratch this copper bar. There we go, so that's it off. Next thing is adding this new bolt with the nylon barrier. So now that that's in place within the spring, I can add this second washer. So that can be slid on. It's hard to see here whilst I'm doing it because it's quite small. So what do we see? There we go. So it's tricky. The nylon washer is nice and tight, so that will hold the spring in position. So next step is adding the nut again. And now screwing it back onto the copper bar. Again, so I have to tension the spring out. Tension the spring out or remove this piece off the end. I might do that instead, as it will reduce any errors, so me slipping and scratching the copper bar. So now I can put this in position like so, and then I can add the actual electrode again. So that's it. Lock these nuts up with an 8mm spanner, and I have to add this little electrode. Let me see if I can do this. There we go. Perfect. Okay, so we now have a bar here. So that means when current flows down through this in an open circuit, so I'll place something on here, an insulator, my keys. So if current flows now into this terminal through this copper bar, it can't make its way into this electrode because this spring is now isolated from that part of the circuit. So hopefully that makes sense. So I'm going to assemble this whole system together now, that being the transformers, the control circuit and this device. Okay, so we have the entire system laid out on the bench. We have part 1 of the project that was introduced to my channel back last year, I think it was September. Then we have part 2 and now part 3 combined within this handheld device. So ignore this yellow piece, that's only there as an insulator to keep the two electrodes from touching. Just in case I hit the foot pedal on the ground there, because the whole system's ready to go for this test procedure. So we have a 5mm bar and we have the 2.4mm rings that's on the model that I am creating for my girlfriend. So I want to mention before I go any further, so I talked about shaping this electrode so that it doesn't flatten the rings, to put a nice radius on it. I haven't done that yet. I'm not going to do that for the test. I'm going to try the machine before I start destroying the electrode. Just keep it flat for this demonstration. So I'm going to weld these 4 rings to this 5mm bar. But first, I want to give one final explanation or discussion on this system as one. When the system is activated using the foot switch and with the weld piece, the stainless bar and the rings placed in between the electrodes, so seen here at this yellow insulator, a high resistance will exist only at this point where a high current will flow from the transformers to the handheld device. So this handheld device is controlled by this on delay timer. This on delay timer controls this high current relay. This high current relay then triggers these 2 transformers, the 2 primary windings, and in turn the secondary winding is the handheld device, the power. So the timer is currently set at 100 milliseconds. I can increase that to 1 second using this potentiometer here. To weld thicker bars or thicker metals, all I need to do is increase the timer's on delay. When the high current passes down through one of these cables and through the electrode and through the workpiece and back up the other electrode, this is normal procedure for the heating process to take place. So this turns the small contact area between the bars to molten metal, and with the addition of the crimping pressure created by the spring, welding of the workpiece will take place. We want the system to remain in its normal state always. This is why I have carefully designed the entire system, the cables, the electrodes, everything you see here to be of the spec and the sizes that they are. throughout the system, it being the device or the transformers, we want a low resistance across the secondary winding to keep the system efficient and effective. So with these electrodes closed, so if I close these electrodes, there should always be a low resistance in normal state. So if the device's electrodes are maintained and cleaned and replaced at these points, there should always be a low resistance. So basically what I'm trying to say, if I put a multimeter on there, the resistance should be low across those two terminals, which is good because the lower the resistance we get here, the lesser voltage drop. So the current will be increased always. Both in theory and in practical, the resistance of the system should be much lower than the workpiece. Otherwise, the system's operations would fail and lose current between the electrodes. In other words, welding will not take place. So, what I'm trying to say there when I mentioned the resistance of the system should be much lower than the workpiece. So, if you can imagine this ring touching this bar, there's going to be a high resistance because there's such a small contact point. If you imagine me now cutting this little cable, this 50mm squared cable, I shouldn't say little, large cable, and take a chunk out of it. If I was to put a multimeter across here and here, the resistance would be very low. So this is important of the system. So the plan is to keep the system's efficiency at its peak level throughout operations. Another thing I want to mention here before I finish off, before I do a test, these cables are rated 50mm square, so this carries a lot of current. Obviously I'm only pulsing it, so it's not continuous current. But if I was to say I was to bypass this timer and hold this relay on, hold these transformers on, these cables will get hot. So that's what I would like to say. I have increased these cables to 50mm squared because I couldn't source 35mm squared. 35mm squared would allow more flexibility within the device here when I'm going to weld the model. So I might revert back to 35mm squared in time. So the only thing with 35mm squared, the length needs to be shortened because you're not going to be able to carry as much current. So that's very similar to if I was to reduce that even more to 25mm squared cable, I would have to bring this device in closer to the transformers. But then I would have more flexibility. But I might go to 35mm squared and leave it at that. But for now, that's what we'll do for the test. Okay, so I mentioned there about keeping the system's efficiency at its peak level throughout operations. So one way I'm going to do this is by adding cooling fans to the enclosure that will hold these transformers and the control circuits. So one of these fans will be sucking in cold air or cool air, and the other fan will be blowing out the warmer air. So it's very similar to my other pneumatic spot welder that I built on my channel. So that's it everyone, we're finally going to test this system before wrapping this video up. Okay, so we are now ready for this testing stage. One thing I would like to point out before I move on here. Well, two things. This little timer is set to approximately 100 milliseconds. So if I bring this foot pedal into view here and I push this, look out for the green light on the timer. So that green light is the length of time the transformer is engaged. So that's weld time. What do we see? There you go. So quite fast, quite rapid. The next thing I want to point out is these cables. So in the previous video clips I mentioned how I'm using the 50mm squared cables. So I've now reverted back to my old cables, which are much shorter. So these cables is the only cables that I have got of the type I want to use. So the type of this cable is Radaflex. So it's quite flexible. So it's 25mm squared. So it's half the size of this. but the distance is much smaller. So for this demonstration, I think it's okay. This 50mm squared cable is overkill. The reason I have went back to this Radiflex 25mm squared cable is because this 50mm squared is quite rigid. It's rigid because it's 50mm squared, but also it's a different type of cable. So if you look at this one, the brand of it is Topflex. This stuff is Radiflex. It's much more flexible. This is like a rubber coating. This is like a plastic coating. So it's much more rigid. So I'm going to now start doing these tests. But first I want to point out, this timer is not going to be changed. I have already done a wee test here, and I can see that the weld time does not need to be increased. So when I weld each one of these rings to these bars, well, I might do about 5 or 6, 3 to each bar. I'm then going to hang weights off the end of the rings to demonstrate how strong the welds are. So we're going to start this now, so here we go. Okay, so we are now going to weld these rings to the bars. Foot pedal's back on the ground. First things first, I'm going to set this 5mm bar into the device like so, pulling back the sliding electrode. Then we are going to place one of these rings in position and pushing the foot pedal. So that's one ring welded. Pulling back the sliding piece and inserting another ring. There's another one welded. So you might be able to see the wee glow there. There's another one welded. This bar is going to look messy. There's another one welded. So I'm actually, well, I have my hand across the two electrodes here, but the voltage is that low it doesn't penetrate my skin. So there's a high current, so hopefully that makes sense. So here we go, we'll keep welding these on. Looks like a, I don't know what it looks like, a piece of art. So that's 1, 2, 3, 4, 5, 6 welded on there in a wee seconds. We're going to weld on the small one now. Pull back the sliding electrode and insert the ring. So what I'm going to do here now is I'm going to bring the camera in close and do the other bar before we move on and do testing. So there is one with 7 rings on it, is it? Okay, so we'll do another one. We'll zoom the camera in for this one. Nice and close. Okay. So you can see the actual welding device, the current, the hotspot. So this other bar now, setting it in. Placing the ring into the bar like so. One welded. Not really in good position, but it's it'll do for this demonstration. There's another one. So you might be able to see that there. I'll zoom in even closer. What do we see how close I can get on here? And I'll try and hold the device in view. So this will be the final ring. It's a bit difficult to get this into view. So here we go. You might have seen that. I was looking at the workpiece. So now I'm just going to show how close I can get to another ring with this device. And if I can get the device out. There we go. So pull back the sliding electrode and just move the device or the workpiece out of the way. So now what I'm going to do is I'm going to move this camera into better position and hang the weights off it, 10k, and see how strong they are. So here we go. I'll do it on the ground. Oh. So here's the 10k, and here's we'll do the first one, the first workpiece first. So setting the weights on the ground and lifting it like so. So you can see there the ring's bending. The ring's bending like so. See, it opened up, but it doesn't break off. So very good. We'll do it one more time. We'll do it with this ring that's welded. So hopefully it doesn't break and fall on my toes, but that is 10k on the end of it. I think it would hold at least 20k, to be honest. So that's it. Back onto the bench here before we finish up. So hopefully you enjoyed that wee demonstration. I know it was quite quick and rushed, but you could see also here, when we zoom out a wee bit further, or we're zoomed out full, so you can see that there's no real blemish or weld to the actual workpiece. So a little bit of emery paper and this little mark would disappear. So, very good. This cable also stays nice and cool. So I can increase this to maybe 800mm for the hard structured model that I will be building. Okay, that's it. The final part 4 of this project will follow soon in the weeks to come. This video will focus on the stainless steel enclosure that will contain all the circuitry components and the transformers. Also, the cooling system will be added. So this miniature wire welder device system will then be demonstrated in the video part 2 of that model that will come, I don't know, in the future sometime. So I started that model for my girlfriend last year, as I already mentioned. The link is in the description for the start of that project, part 1. So to wrap this video up, if you haven't seen my video of my homemade pneumatic spot welder, please do so. It's very similar to this, only it's a bit more sophisticated. So yeah, moving on. One thing I should probably point out, within that pneumatic spot welder, I built my own transformer. So these transformers are modified transformers out of a microwave. So it's very important not to miss out on that pneumatic spot welder video. So a shorter video will follow on this pneumatic spot welder in due course, without focusing on the lengthy design as I did then. I hope you enjoyed the video. Please hit the thumbs up if you did. It's a project I've been meaning to cover all year to finally get on with my girlfriend's model, the heart structure. If you want to see this project evolve, and that one, and other projects, similar projects, please subscribe and hit the post notifications bell to see the latest from my channel. As you can see, the welder has now picked up since I started this video, or since I started part 3? Part 3 of this project, meaning the final part of this mechanical iris, my large aperture, and the e-bike build will follow soon. So that's it. Thank you for watching, everyone, and goodbye. Okay, so I have added this additional stage, as I always do. So I'm going to discuss quite a few photos here of the fabrication stages. Okay, so for this video, as you know already, I started off with the capsule. Then the drawings were used to create the new parts for part 3 of this video, or this project. So here we have the stainless steel scribe plates. So you can see there I have the holes drilled in the special tab before I cut the tab out. So here's the templates alongside the new plates, the supporting plate and the tab for the electrode. Here I am ready to weld this tab and the supporting plate to the capsule. So here is the capsule with the supporting plate tacked in position. So this supporting plate was required for the mounting of this new tab. So rather than weld this tab directly to the capsule, this tab is welded to the supporting plate, and the supporting plate is welded in the appropriate places. So at this stage, the tab and the supporting plate and the capsule was finished, ready to be welded. Here I started forming the 2 copper electrodes. When I say forming, I mean drilling the holes, bending them, cutting out the notches, and yeah, tapping the holes too also. At this stage you can see the copper electrode is in position, the fixed electrode and also the sliding electrode. So the fixed electrode is bolted directly to the tab using two M5 domed head stainless screw bolts. We are now ready to add this second tab, the second piece of the fixed electrode. So this is the electrode with the little bend in it, the little 10-degree bend. At this stage you can see that this is complete. This second piece is now bolted to the fixed electrode. So we can see how this little small part, this little small electrode takes advantage of the sliding electrode by working off the middle of the sliding electrode rather than the side of it. So this keeps the forces centered to the copper bar when the copper bar is being pushed or pulled into the capsule. So this benefits the reduction of drag on the insulators, and in turn it keeps the sliding copper electrode from sticking. Okay, at this stage the device is nearly finished, ready for polishing. But first I have to finish off the device by adding the spring. So here I am tapping the two holes for the mount point on the sliding electrode. So one of these holes is to apply more tension at the pinch point, whilst the other hole is to apply less tension at the pinch point. So here we can see the spring doing its job, pinching the 5mm bar to the 2.4mm rings. At this stage the miniature welding device, the handheld device, is finished, ready for polishing. However, as you can see in images, the little insulator around the spring, the mount point, is not attached at this stage. So this insulating barrier is really vital for this little system to work, this little device. So if this insulator wasn't there, these copper electrodes would be shorted out even before the electrodes meet at the pinch point. So the little device came together quite well in the end up. The following images shows various views of the miniature welding device. So by this stage the only thing was left to do was attach the little insulator, the M5 screw, which has the insulator barrier on it, and the next thing was polishing the entire device. Then the next thing was obviously attaching it to the control system that I have previously created. So again, various views of the little device pinching the round bar, the 5mm bar and the 2.4mm rings. So here is the capsule stripped, the mechanism stripped, ready for polishing. So we have the edges all sanded, we have the edges of the capsule chamfered at 45-degree angles. First we had to finish off welding the device. So this was done using the TIG welder. So there's me, the madman, in the background. So here we have the capsule welded at one side. So 6 places, 6 small little beads. So it was important not to weld too much at this, as I would only distort it. So the chamfering of the edges came after the welding, seen here. So this is the little device polished, nearly polished, about 50% there. So it looked much better than I thought it was going to look. I didn't think I was going to go to the extent I did and leave it with a mirror polish right over, a mirror finish right over. So here's all the parts that make up this smart mechanism. So at this stage, after polishing, you can see the finish there. You can see my phone in the background or in the mirror finish. So I could have took this to extreme. I could have sanded all the welds down and left it with a better finish, but it's not required for this little project. I would only be overkill doing that. So again, there's the mirror finish, the reflection in it. Okay everyone, so we're coming up to the final few images here of this project. So we have the little yellow insulator, the little nylon washers, the mirror finish and everything complete at this stage. I hope you enjoyed this project video. As I mentioned earlier, please hit the thumbs up if you did. I know it was a very time consuming and a very heavily detailed one, but I think it was required to demonstrate the lengths I went to get this one to work as it does. If you want to see this project evolve, please subscribe and hit the post notifications bell to see the latest from my channel. Thank you everyone and goodbye.